Tetris. Let's begin. First, I want to jump right into my motivations of doing this.
I'm a fan of this. Okay.
Okay, so I have done a lot of research about existing reinforcement learning agents, and I found out that surprisingly, after 5 years, so I'll just share the same format like this. Just a clone from this other project to the others. They have really fully implemented the Tetris environment into reinforcement learning, and I believe that this is the reason why none of them can perform any T-spin. So what is a T-spin? T-spin is a crucial aspect of competitive Tetris, which you have to place this T tetromino into a T state and then rotate it before it's become fixed. And this requires a lot of effort and skill. So we have tried out a different approach to this problem. In this thesis, we're gonna show you a deep understanding about the Tetris environment. We have created a reinforcement learning Tetris agent that can execute T-spin. We're going to show you the study about the exploration and exploitations in Tetris. And we have integrated something called professional replays that will further enhance the agent performance. And last but not least, we'll show you about our future development. First, let's talk about some basic concept related to this project first. Reinforcement learning is an area in machine learning where we have the agent, we're trying to learn from experience and take actions. The environment will provide feedback for the agent based on the agent actions. The policy is what the agent came up for certain actions. And explorations is the process of the agent trying out different things to discover new information. And exploitations is where the agent will use the best known knowledge that they explore and then use that to get the maximum reward. We have something called Q-learning. Q-learning is a reinforcement learning algorithm that will give you an optimal action value, which is called Q values, for each state action pair like this. And it will store in something called a Q table right here. But what happens if we are dealing with problems that have millions and billions of states, which we come to the deep Q learning. Deep Q learning is a combination of Q learning and deep neural network, which is to use a neural network to approximate the Q value functions. The input will be the state, and the output will be the Q value for all possible actions. Reinforcement learning have a lot of applications in real-life problems, such as self-driving cars, industry, trading finance, new recommendations, and especially in gaming. The reason behind this is, unlike supervised learning, where you have to rely on label data, reinforcement learning learns through trial and error, and this is suitable for problems that have dynamic environment, which like Tetris. So speaking of Tetris, Tetris is a 40-year-old game which play on a 20 times 10 game board, and the player can manipulate 7 pieces of tetromino. The player can rotate it or move it to the left, right, or dropping it. So we will take the Tetris and put it in the reinforcement learning environment. The game state will be represented as a 2D grid that represents the game board. The action that includes the tetromino in type, the next tetromino in Q, and the whole tetromino. The action state is all of the possible actions that the agent could make by rotating this piece, moving it to the left, right, or dropping it. The reward system is based on the number of lines clear and in additional points for T-spin execution, back-to-back combos, and script. And we also have designed all of it on a rig-based coordinate system so that we can track the movement of the piece to calculate this rotation much more easier. And this leads us to the next part, the kick mechanics. This is one of the big differences from my project to the others. This is one of the most important things for the agent to learn how to execute more advanced tactics. In Tetris, there's something called predefined kick table right here, which lists all the offset that the piece can turn into places when rotated. To the right hand here, we have the data to implement, and to the left right here is the position of the piece with it turn out when testing. So let's have a clear look about this kick. I have an example of the kick mechanic right here. Let's talk about if we don't have the kick mechanic first. If we don't have the kick mechanic, this piece right here is just going to be stuck here and become fixed because there's something blocking the way. But because we already implemented the kick mechanic, so they will have to pass some tests by testing out, and they can rotate from that position to the really tight position right here. And let's look at a real game scenario. We can see right here, we have a piece who is trying to drop down, and without the kick mechanics, this piece right here cannot be rotated at all and will be stuck right here. But because we have implemented the kick mechanic right there, which will push it down here, so it can push it right here and result in clearing 3 lines using one piece, making the reward higher. So let's talk about the explorations and exploitation in Tetris. Explorations, as I mentioned before, is the process of the agent trying out different things, which in Tetris is trying out different moveset. You can see where it's trying out random to find out the best optimal strategy later. And exploitations is where the agent will use all of its known knowledge to develop a strategy. And you can see it's stacking up right here, and it can spin. And balancing these two is really important in reinforcement learning. Too much exploration can lead to suboptimal path, like short-term performance. And too much exploitations, the agent will lack of strategy because they have nothing to exploit. And there are a lot of strategy to balance these two, but we are just going to use an epsilon greedy with decaying epsilon. In epsilon greedy, with a probability of epsilon, the agent will explore, and with a probability of 1 minus epsilon, the agent will exploit. So ideally, we'll want the agent to explore as much as we can at the start of training and exploit later. So how do we enable the agent to do explorations? Well, we have implemented an environment so that the agent will have the ability to check true of this future state or possible state right here from the current configurations of this piece. It will try out different rotations and piece placement like this, and it also do the kicking method, which will kick the piece into some really hard to reach position, which further deepen the exploration part of the agent, making it more viable for studying more complex strategy. And all of these states will be assigned with a score for exploitation purpose. So in exploitations, the agent will try from that, we just assign score there to try out like choosing actions. So the process of exploitation is the agent. As you can see, at the start of the training, the frequency of T-spin happening is rarer than the later part. And the same goes for quad. As you can see, at the start of the training, there's no quad execution at all. But to the end of the training like this, you can see that it's happening more frequently. It's shown that the agent have to do exploitation about what knowledge they have learned. It proves that the epsilon strategy have shown some work. And yeah, so here's a real example of how exploitation works in Tetris. This is my agent at the axis of 1,500. You can see that it still have some pieces that trying to place anywhere to find out the best strategy. And this agent after training, these have developed some kind of strategy that they stacking up and trying to maximize results. Next, we have interact something called Pro Replays. This is a content of 245 gameplay from top 20% of Tetris player, which is a Tetris online game. And the agent will have 20% of using this Pro Replay instead of the random buffer in the experience replay. And of course, it's better than random replay because it's from professional player. So in order to handle all of the mechanic that we implement and also the exploitation and exploration, we need an algorithm that can make use of all of it. So why do we choose double deep Q learning over deep Q learning? Well, the most obvious reason is that deep Q learning are prone to overestimate Q values in other research. So the obvious reason is because of the single network architect. So what is better than one network? Two networks. Double deep Q learning use two networks, the primary one and the target one, and they evaluate, like we separate everything, so it's much clearer and will not be overestimation like the deep Q learning. And this has shown some better capture of the more complex strategy revolving in Tetris, and better game work management too. The result in comparison to the right here is my agent. And to the left here is one of the best agents in the past 5 years that using deep Q learning. And my agent can perform a T-spin and a variety of complex tactics. It can survive over than 1 hour and perform 91 T-spin, while the other agent right there can perform not T-spin at all. Yeah, and you can see right here it can consecutively setting up for T-spin. And one point to be mentioned here is the impact of the pro replays into this agent. After implementing the pro replays, the performance of the agent has skyrocketed from only doing 9 T-spin to 91 T-spin. And they have proven some kind of, we could try a hybrid approach to reinforcement learning problem, whereas the reward is fair for the future. And to my conclusions and future work, we have proven that we need a deep understanding about the environment in order to solve reinforcement learning problems. And we have to separate, implement, and create a reinforcement learning Tetris agent that are able to execute and perform T-spin, which is a crucial part in competitive Tetris. And we have shown a glimpse of hybrid approach to reinforcement learning problems. In the future, we could try out something called state action pruning, which will reduce significantly the action space. We will experiment with a genetic algorithm with mutation for each generation, and we'll experiment with prioritized experiment replays rather than the traditional one, because it's shown some promises. And thank you. That's all of mine.
Okay, very good. Now my first question, the double Q learning.
Yes.
Is your proposal or you learn from some research book?
I have learned some research book, and the only difference is that we implement the
Okay. So in that case, for example, for this slide, I should mention the name of the paper.
I'm sorry.
Because if not, without that, you
So-
cannot distinguish
Oh,
between
okay.
your proposal
Because
and the
my
proposal from
supervisor,
another.
Dr. Wang, said that I need to keep the slide simple as possible. So
Yes, but just
I will,
2 lines of the reference.
Okay, I will.
It's much better. Now, my second question, because in Tetris, we have 2 kind of play, 2 type of play, single player and
Yes, and multiplayer.
multiplayer.
Yes.
So have you ever tried?
I am implementing that, but we're having some problem with sending garbage line because it's not resistant to the system.
Yeah, it's
So
much better if you try your model
Yeah,
with
and-
yourself, for example, how
yeah,
to see
okay.
how.
Just I know, but like I haven't.
Of course, yeah, it's the implementation is much more, of course, much more interesting, right?
Yeah.
Because this for the program played by
Because
by
like
itself.
my first.
Wait for the supervisor.
Oh, okay, sorry. Sorry.
Right.
Yeah.
So you implement a single player model,
Yes.
and you compare with the competitive other models, right?
Yes.
And you mentioned about the maximum score of your model, but no maximum score.
I have. I think.
This- yeah.
Yes, over 1
That's
hour.
your model.
Yes, it's
How
my
about the
model.
other
Yes.
models?
So because they didn't.
They survive for 15 minutes.
Yeah.
15 minutes does not mean
The score.
the score, right? How about the score?
Because as you can see right here, this model can only perform like
Yes.
quad clear,
Yeah.
and the T-spin which already give a higher
Okay.
score than
Okay.
quad clear, and they can execute like 3 or 4.
Okay, yeah. Of course, the T-spin is the one of the most complicated action, right? And but that's not all,
I know, but because
right? So, what do you think about besides the T-spin, of course? Yeah. What are the factors that contribute most to the performance of the models? Yeah.
Okay, so as I mentioned before, we have implemented something called kick mechanic, right?
Mhm.
And because I have shown some
And
examples.
what's the big, yes, right.
I show some example right here. It's not only about T-spin. The model can also execute a lot of quad clear and triple clear right here. So the model can perform like over 200 quad
Yes.
clears.
Yeah.
And
Okay, good. In the slide about the introduction about the reinforcement learning, we have different component, agent, the next slide about the reward, about action space. You should, where is your
This one.
okay, game state, how many states? We should present more clearly, more concretely for this game. For example, game state, how many number of states? Action space, for example, how many type of actions? Because not every people play Tetris, and not every people know what is the reward system, what is the input of the reward, and what is the you should mention because this reinforcement learning is very general. Research is a research, but for Tetris, it's a very concrete application. So in this case, you should mention very concretely about game state, what is and what is the interaction of the reinforcement process in, for example, from the state, from the reward, and from the action. Three important key components of the learning system. And from that, circle dimensions of learning objective function. Which one you want to minimize? For example, is the training process and is the deployment process, how to apply the models. Because without that presentation, many people could not understand how your system works. Okay, so explain more about what is it?
So
How many states are there?
about the game state, I have thought that this thing is a 2D grid that represents the game world. So that's the first game state. But then the action space, I have already talked about the
How many actions?
all of the,
1, 2, 3,
no,
4.
all of the possible actions that the agent can execute by rotating this clockwise and counterclockwise
Yes.
and placing the piece.
How many totally?
A lot, I guess, like 8, more than 8. No,
You need
actually,
a very concrete number because you implement it by yourself.
yes, I know, but like, because like when I talk that the action state is all of the possible movement. that-
Yes, but you know all the possible movement, but
okay,
the audience could not imagine, how many actions are there in the action space. Right. Now about the reward.
Reward system is based on the game score itself.
Yes.
This is the number of line clear and
Yes.
additional point for executing T-spin.
And how those factors integrated in the objective function. So show us the objective function of the training process.
So I have to put it in the slide. Right?
Sure. Because that's very important. The key information about your research.
No, surprisingly about this research, I found out that the reward function we use, the basic reward function for
Of course,
the And
So now open your report. Show us about the training objective function. The objective function of your training process.
actually, I'm not clear about the objective function that you're mentioning there.
You do the training, right?
Yes.
Yeah. It takes some parameters, some
Oh,
values,
okay.
and after that, you produce something and you compare the precision and the real.
Oh, I might not have the thesis right here because it's a different computer.
Of course, because you put, because now everything you put have the reference and even you could use ChatGPT to generate your documents. But your task is to understand what is the most important part of your study.
Yes, I'm telling you.
Yes.
Okay, so the most important part. Right
No, I'm asking you about the objective function.
See, I am not hearing about the objective functions that you mentioned. Right.
You do the optimization, right?
Yes, I know.
So I need the function your program try to optimize.
Oh.
Because training process is an optimization process.
Yes.
So I want what is you want to optimize.
If this is a diagram we use for your
Yes,
machine,
exactly.
so you have the optimize here and you want to find a target,
Oh,
and then
okay,
you come
so
back,
you're talking
and then
about the
forget
target.
and come back here. So what is the objective function in this one?
You know, now you can generate the whole thesis using ChatGPT. Right? Will you agree with us about that? But your problem is, your task is to understand which part is the most important
Okay,
component
I'm
and
going to
present
talk.
what.
Yes, I'm talking. The most important part about my project is I find out about because why the other project cannot execute T-spin is because they have a naive understanding about.
I don't believe so, because I don't believe that. That's your statement. I have the right to believe on your statement or not. But you conduct some optimization program,
Yes.
and I wondered what is the function you wanted to optimize,
right? Yeah. If you.
not a function. You understand what's the function, right?
I do understand.
Yes.
I really
It
do.
should be minimize of the function and the number of parameters you wanted to optimize.
So.
So open your thesis, the text. So open your thesis. And please let us know what is the optimized. Yeah. Yeah, for example, you open the page number 10.
Give me a second because it's kind of laggy.
Yeah.
I'm trying to reconnect to my PC right now, so it's kind of laggy a little bit.
Yeah, this is the objective function of the Q-learning. Now let's take example of Q-learning. You optimize the Q function of two parameters S and A. I saw it on the slide, right?
Yes.
That's the objective function.
Oh, okay, so you want to.
Yeah.
Okay.
Yeah, explain very clearly what is S, S is what? A
Okay,
and
so-
the domain of S,
Oh,
domain of A, right?
Okay. I think I have this on my computer. So it takes a lot of time. Oh my god.
Then come back to the slide.
Okay. Okay, so if you ask
Yeah,
me,
yes, yeah.
okay, so the S is a state of
Yes.
the actions.
Yes.
The S is S with the.
Of course, that's the
Okay,
reason in
Okay, so what do
machine
I
learning.
optimize in this?
Yes. So what is the domain of S? Domain of A.
Can you explain more clear what?
Yeah, for example, action. A means action.
Yes.
Right? How many actions are there in
Okay,
your
so-
task?
Actions is include all the over it. I don't know how to explain it.
No, action is a set
Yes, a set of movement of the
of
action.
movement.
and
So
execute.
how many items are there in a set for the Tetris?
More, I can show you all rotations.
Yeah, I need a very concrete number. How many actions are there?
I'm gonna say it's a lot, okay? Because like at one position, right? You can rotate it 8 times and then move to the right and rotate it 8 more times. So it's
So
gonna
in
be like.
summary, how many total? Right. That's why I wanted to know the actual.
The actual action.
Yeah.
Oh my god.
A very concrete number. Because this formula is a popular and commonly used for any reinforcement learning task. But when you apply a general model to a specific task, you should present very clearly and concretely,
About the action.
yes, every component of the reinforcement.
I only remember it was about like 2 something. Can I reach back to you later.
Yeah, of course, sure. Okay. Now, explain us about what is the difference between exploration and exploitation.
Okay. You want me to explain it in the
Sure.
context of Tetris or
Sure.
just general? Okay.
Yes.
So, I'm gonna just turn this back up again. Oh my god.
Exploration.
Okay, so I just want to talk it right here because it took too long to doing all this. Okay, so explorations is where the agent will try out different placement. No, actually, I have this slide right here. It's much more easier to understand.
Yes.
The explorations is where the agent will try to explore all of the actions that it can make by just doing all the actions that you just
Try
mentioned.
all everything possible.
Try everything possible.
That's exploration.
That's exploration in the context of Tetris. And exploitations is where, because the agent already learning of this already, right? It's not stored in the experience buffer. And then it will try to use that knowledge and then try to do some move action that generate the best maximum reward that you got. That's in the context of Tetris right there.
I would like to ask one of the audience, what can you distinguish between the exploration and exploitation?
Okay. So,
Yeah, the audience can understand about that. The differences between exploration and exploitation.
Exploration kiểu mình là văn đúng.
The exploitation is like after the exploration part, they have some knowledge as I know. So they will use that knowledge to gain more
yeah,
points.
he's right. Yeah. He's nice somewhat.
You are very too close friend.
No, I don't know any of this guy at all. I am in ICT and they in TS.
Okay. So I finish my question. So
So it means that in this tethering scenario, so we have a grid nine multiple by 9, right? For example, because previously you show some of the grid.
Yes. This grid, right?
Yeah, the grid here, and then,
No,
the next two slides you have the grid 9 by 9 multiple by 9.
Which one? This one.
Yeah, that one. You have every
Okay, so-
puzzle with the
Okay,
with
so
the
let's
grid 9.
let's
Finish.
I'm sorry.
You have the puzzle 9 by 9 there. So when you do the exploration, you try to find every possible puzzle around the 9 multiple by 9 grid, right?
Yes.
And then with the exploration,
And we'll check.
you try to find the best action, best speed.
No, best actions that lead to best reward. It's not speed. Because like when you're testing spin, right, there's sometimes this will collide with other pieces on the board. So it has to be viable. This thing cannot. You have to be viable so that we will take consider and it has to gain some reward. It's not just raw speed and stuff.
What is this reward mean exactly?
Okay, so let's translate on this board to here, right? This is the coordinate of the piece will turn out when shifting from the kick mechanism.
Consequence of the
Yeah. So, for example, we can see the test 3 right here, right?
yes.
It will like push the piece up instead of just staying here, push up one square. So it will register that using that board into the grid-based system right there, and then check for collisions. If there is collision, then the test will fail, and we'll pass to the next test, and repeat until we can execute any spin, and if not, then the piece is just gonna stay the same.
So I just emphasize that I totally agree with the professor's view about organization and problem. Everything like what actions that you can do, communication you're with, and everything like rewards, function, everything. So you should organize better mathematically in the thesis.
Now, her comment is about the presentation of the problem. Yeah, you have formulations and you should explain systematically. For example, the whole process, step 1 to step and the loop, and after that, call important components of your formula, for example. And in this case, you should present the learning problem more clearly. For example, in this case, you assume that you could see previously, is that true that you can see the previously of the next item of the Tetris, right, on the right side?
Yes.
But in many other cases, the next item is not available still, right? So you should state the problem very clearly, and it concerning about the parameters of the learning program. Okay, great work. And other comments from the audience? No. Now my last question. What next?
My plan is to take a break first for 1 week because
1 week break?
Yeah, because in the past 3 months I lost.
No, I'm not.
Okay. So my future plan.
Your career path.
Okay, my career path. I think I will attend to master, and I'm considering with studying in here or going to Germany. Next up, I will try to apply for the VIN data, big data scholarship something, and if I can pass it, then I will attend to the uni, and if not, then I will just.
It means that you still receive funding from your parents?
Kinda, half of it. I'm making money by myself now, and I'm trying to save up for.
Okay, you wanted to apply for master, you apply for some internship somewhere, and did you receive any offer?
I haven't.
Ever?
Yes.
When you will have?
I'm planning to join to the summer, like in the April or May. So.
Yeah, it's too late now. At least in your pocket, at least you have
because
more than one offer for all job or salary.
Oh, actually, if job, then I'm having a intern job right now in a.
With salary?
Yes, with salary, but.
And good for your daily life.
I would say enough to maintain my daily life.
Because you graduate already. If you graduate from USTH, you still don't afford by for yourself.
Yes,
It's not
a
considered a success student because you have spent 3 years here for career.
Because actually I'm planning to attend master first and then I will work.
Yeah, in many countries, if you want to attend a master course, you have to borrow the money from them.
Yes, I will take.
Not from